Okay, so we're looking at lesson 4 today. We're going to look at reference frames, average speed and average velocity, mass and weight, and then we're going to look at density. So hopefully after this lesson you will be able to do reference frames, average speed and velocity, mass, weight, and density. So the coordinate system an observer uses to measure positions, velocities, and acceleration is called your reference frame. And every single observer has a reference frame that is attached to your head. For the present, our reference frame for discussing position, velocity, and acceleration is going to be attached to the head of the observer, and they are going to be standing on a flat surface of the earth. I know the earth isn't flat, but it curves at such a small degree that for what we're going to be looking at, it's okay to say it's flat. And then our reference frame will have 0 velocity and 0 acceleration with respect to the surface of the earth. Obviously the earth is moving, turning the whole time, but when you're standing on the earth, you don't feel it. You are not moving. You have no acceleration with respect to the earth. So that's going to be our reference frame. For average speed and velocity, in physics, we find it helpful to distinguish between the length of a trip and the distance between the starting point and ending point. So if you've ever heard someone say, it's 20 miles as the crow flies, or something like that, that means from where you are to where you need to get is 20 miles. But that doesn't mean that you can get there in only 20 miles. You may have to go further because of where the existing roads are. So if we look here, going from home to school, the distance is 7 miles because we have to travel 3 miles on this road and then 4 miles on this road. But the displacement is 5 miles, and it's at an angle of 36.87 south of due east. So there's a difference between distance and displacement. Your average speed is going to be your total distance traveled divided by the total time of the trip. And the average velocity is the displacement divided by the total time of the trip. So we're going to look at some examples. Roger jogged 7 miles north in 1 hour. Then he drove due east for 1 hour at 50 miles per hour. Then he drove due south for 30 minutes at 40 miles per hour. What was his average speed and what was his average velocity? So first off, we are going to draw a little picture. So here's Roger. This is where he starts. And he goes 7 miles north in 1 hour. And then he went east 50 miles per hour for 1 hour. And then he drove south for 30 minutes, so that's 0.5 hours, and his speed was 40 miles per hour. So the first thing that we need to do average speed, we're going to do total distance over total time. So the distance, first he traveled 7 miles, and then it says he traveled at 50 miles per hour, but he traveled for an hour. So that would be 50 miles. And then he traveled 40 miles per hour for half of an hour. So he went 20 miles during that time. So that's the total distance. And then his total time was 1 hour plus 1 hour plus 0.5 hours. And so if you add those up, you're going to get 77 over 2.5. Which is 30.8. And we need to look back at the problem. How many significant figures do we have in all of our numbers? We have 2 sig figs. So we're going to round this to 31. And then we're going to have miles per hour. Because distance is miles, time was in hours. Now the book has it in miles per minute, and that's fine if you want to do 60, 60, and then 30, and then you would have it in miles per minute. That is fine with me. It didn't ask for a specific unit for your answer, so either one of them would be accepted. Okay, for this next one, the average velocity. You're going to do the displacement divided by the total time. So the displacement is the part we're going to have to figure out. The time did not change. It's still going to be 2.5 from this 1, 1, and 0.5, or 60, 60, and 30, a total of 150, whichever one you want to do. So I need to come back over here. Roger started here, and he went up 7, over 50, and then down 40. So he went over to the right 50, and then this isn't drawn to scale, but if this is 7, this total part was 20, so this part here would have to be 13. And so you have a triangle there, and it's a right triangle. And so we need to know what is the hypotenuse and what is our theta. So we're going to do hypotenuse squared is 50 squared plus 13 squared. And so your hypotenuse should be 51.66. And then your angle, you're going to do tangent of theta equals 13 over 50. And you need to make sure you are in degrees. Okay, so our displacement is 51.66 at, it's a negative 14.57 degrees because we started at the positive x-axis and we went down. And when we go down, when we go clockwise, those are always negatives. So then we just have to divide here. So you only have to do the 51.66 divided by the 2.5. And so you should get 20.66. The angle stays as is. And so again, we have 2 sig figs, so we're going to do 21 at negative 14.57. And then velocity is miles per hour. So that would be the average velocity. Okay, so that's how you do average speed and average velocity. Now we're going to look at mass and weight. Physics is a science of observation, thought, experiment, and measurement. Many people think that physicists try to discover the why behind why physical objects behave the way they do, but that's not true because finding the why things happen is impossible. It's like asking my little boy, why did you do that? He doesn't know. He can't tell you that. He just decided to do it. Same thing with objects. They don't know. That's just what happened. Instead, physicists observe what happens under a set of circumstances, and then they try and find rules that'll let them forecast what will happen if the circumstances are changed. So they don't try and find out the why. They just try and make rules to help us know what's going to happen next time. And the rules can be called laws. And the laws are not always fixed because sometimes we're going to throw out an old law if we can find another law that will make our predictions more accurate. So if it's a law, that doesn't mean that it's going to always be a law. It could get changed by something that helps us make it better. So at sea level, the attractive gravitational force exerted by the Earth on a mass of 1 kilogram has a magnitude of 9.81 newtons. So you have to learn this number, 9.81. Okay? If you don't learn it, then you're going to mess up a lot. 9.81. It's always vertically downward for the direction, so things are always coming closer to the Earth. They're falling. This is our formula for weight equals mass times gravity. You are going to be able to make a formula chart, or a formula sheet. So y'all can go get a 3x5 note card, and you can put any of the formulas you want on it. You can put anything on it because I'm not going to look at it before your test. It's for your benefit. Now, most of the formulas, if you look in the back of the book, there are a lot of formulas back there, I think. Now that I'm saying that, I'm questioning myself. Maybe not a lot of formulas, but there are some formulas back there. And so that's something that you can look into. I'm trying to find the page. They're starting maybe, well, it's more tables and everything on page 761, but you'll find that those are useful. And then they have your information. They have a lot of information in the back, and so it's not a ton of formulas. So you may want to make your own formula sheet on a little note card, and you can make a new note card every test. You can do whatever, but this would be a good one to write down so that you can learn it later. I mean, so you don't have to learn it. You can just use it on your sheet. So the weight of an object is a measure of the gravitational pull of the Earth on the object. Hopefully some of y'all are aware, if you go to another planet and you put a scale down, your weight is going to be different because they're going to have a different gravitational pull. Y'all may have been to the place in Shreveport, Cyport, where they have a scale, and they have them at other places too, and you can stand on it and select a different planet, and it would tell you how much you would weigh. And if you're on Jupiter, then you're going to be way heavier, and if you're on maybe, I don't know, Mercury, you may weigh less. But that just depends on the gravitational pull of the planet. The mass is the property of the object that is attracted by the mass of the Earth. Your mass does not change. So your mass stays what it is no matter what planet you go to. You're not going to change shapes. Your mass is going to be the same, but the weight is dependent on the gravity. So mass is the measurement of the amount of matter, and so matter doesn't change. So that's why your mass is going to stay the same amount. Just because your location changes doesn't change your mass. Weight, on the other hand, could change with location. So if you weigh yourself here and then you go to the top of Mount Everest and you weigh yourself, you're probably going to get a different weight just because of the change in the gravitational pull at the top of Mount Everest. If you look at your planets, like I was saying, your mass is the same on every single planet, but your weight is different due to the different gravitational pulls. So mass stays the same, weight does not stay the same. So let's look here. An object has a mass of 100 kilograms. What does the object weigh on Earth at sea level? So we're going to use this formula. Weight equals mass times gravity. So we're looking for the weight. How much does the object weigh? The mass is 100, and our gravity number is 9.81. And so if you multiply, you get 981. We have 3 sig figs on 9.81, and we have 3 sig figs on our 100. So that is 3 sig figs, 981, and then the units is newtons. And so that would be your answer. Okay. The weight of an object is 475. What is the mass of the object? So again, we're going to use our formula. They tell us the weight is 475, so we plug that in. We don't know the mass, and then gravity is 9.81. So then we're going to do 475 divided by 9.81. And you should get 48.4199. And we round to 3 sig figs because we have 3 here and 3 there. So 48.4. And mass is in kilograms. And so that would be your answer. You will need to learn your units because that will be part of your test, putting the correct units. So if you want to put that on your note card, you're welcome to. As you get more familiar with the problems, you'll get more comfortable with putting the units correctly. So now we're going to look at density. Density is a number that relates the mass to the volume. And we use the symbol rho. It's a Greek letter. We use this little symbol here for density. So this is our formula. Rho equals mass over volume. So again, if you want to write that formula down, whenever you get a note card, you can add it to it. For now, you can just make a little sheet in your notebook if you would like. And that way you can just continuously add to that sheet. And then every test you can pull what you want to put on the note card. So density equals mass over volume. If you look at table 4.1 on page 23, you'll see the density of a few solids, liquids, and gases. And it's also in the back of the book, starting on like 761, I think is what I said a minute ago. You can look up those informations. Okay, so a block of copper weighs 4,650 newtons. What is the volume of the block? So we're going to start with our formula. They tell us the weight is 4,650. But if you look here, we can't plug weight into that formula. So we're going to have to start with weight equals mass times gravity. 4,650 is our weight. We don't know the mass, and we know our gravity is 9.81. So if you divide, you should get 474.006. I'm just going to write 474. We're going to use the whole number from our calculator, but I'm just going to put those 3. So then it says a block of copper weighs that amount. What is the volume? So we don't know the volume. We know the mass is 474 and some change. To find the density, we have to look in the formula. So y'all need to look on page 23. And we're looking for copper. It's over on the left side. Hopefully you're seeing it. It's 8,920. You won't have to memorize these numbers. If you need them, they'll either be given to you or you'll have the table to use them. So don't worry about having to memorize different density numbers. Okay, so we're going to multiply by V. So we have 8,920. V equals 474. And then divide by 8,920. And you should get 0.0531369, etc. Now we need to look back. How many sig figs do we have in the only number they gave us? There are 3 sig figs here. So this 0 does not count as a sig fig. This is the first one, this is the second one, and this is the third one. And that 3 doesn't round it up, so we have 0.0531. And then for volume, the units are meters cubed. And so that would be your answer there. Okay, so hopefully that helps you a little bit with how to use those formulas. On your homework tonight, you have 22 problems, so make sure y'all do those so we can go over them tomorrow.